Imagine you are in an old darkroom, the red safe light humming, trays of developer and fixer lined up like ritual bowls. On the enlarger, a negative hangs suspended, a ghostly pattern of light and shadow, and with each careful dip and rinse, a single image slowly resolves from a cloud of possibilities. A face, a street, a single raindrop frozen mid-fall. For a physicist, that slow emergence is a perfect picture of our dilemma. The math hands us a negative full of potential, and something, a process, an event, a decision, turns it into a single, crisp fact. Now picture the same moment from inside a mind. The instant a color arrives, not as wavelengths on a chart, but as the lived redness of a rose. That private, unmistakable fact, the felt quality of experience, sits beside the darkroom image like another kind of development. Both scenes trace the same strange choreography. From processes we can describe in objective, third-person terms, the evolving wave function, the pattern of neuronal firings, there nonetheless emerges a single, definitive first-person fact, a particular measurement outcome, or the felt quality of experience. In other words, the math and physics give us a full external account, yet they stop short of specifying which subjective fact actually obtains. This is where two of the deepest puzzles in science and philosophy collide: the quantum measurement problem and the hard problem of consciousness. Today, I want to walk you along that collision. I'll speak as someone who has spent long nights with equations and longer mornings with coffee trying to make sense of the world. First, the measurement problem. Quantum mechanics gives us a beautiful, precise rulebook. Systems evolve smoothly and predictably according to the Schrödinger equation. But when we measure, the rulebook seems to flip. Instead of a smooth wave, we get a single outcome, a click, a flash, a yes or no. The theory itself uses two different rules, one for evolution, one for measurement. It never tells us when or why to switch. That's the measurement problem. Second, the hard problem of consciousness. Neuroscience can map neurons, chart firing patterns, and explain behavior in exquisite detail. Yet none of that explains why there is something it is like to be a subject, why the firing of neurons is accompanied by the redness of red, the taste of coffee, the ache of longing. Why is there experience at all? Now here is the provocative move. These two problems share the same logical shape, as I hinted at in the beginning. In both cases, a complete third-person description, the wave function for quantum systems, the physical description for brains, fails to determine a first-person fact, which outcome occurs, or what it is like to be that system. When you strip away the technical language, the measurement problem and the hard problem look like siblings. If this puzzle is a story, then we have several key characters. Let's introduce them. First, collapse. Collapse is the dramatic one. In some interpretations, the wave function literally collapses, possibilities become a single actuality. But collapse is a rule that appears in the math without a clear trigger. Where does it happen? At the detector, in the lab, in the brain. Von Neumann showed that you can slide the boundary, the so-called Heisenberg cut, anywhere along the chain from particle to observer. Nothing in the physics tells you where to stop. That's unnerving. Note that not all interpretations of quantum mechanics assume the collapse of the wave function. For example, in the so-called many worlds interpretation, every branch of the wave function becomes a parallel reality, and nothing collapsed. We will discuss that later. But my main argument today is that if we assume collapse happens, which a lot of quantum mechanics interpretations do, then the measurement problem and the hard problem of consciousness turn out to be the same kind of problem. Second, decoherence. Decoherence is the peacemaker. It explains why macroscopic objects do not show weird superpositions. Interactions with the environment rapidly suppress interference and pick out stable pointer states. Decoherence tells us why we see cats alive or dead rather than both in a smeared superposition. But it does not pick a single outcome. It turns a pure quantum state into what looks like a classical probability distribution. But the underlying entanglement remains the world looks classical. But the theory still has not said which branch is real for a specific observer. Or, in other words, if we want to emphasize the connection here for a specific conscious mind, decoherence solves the easy problems, It leaves the selection problem, or hard problem, untouched. Last but not least, consciousness. Consciousness is the wild card. Some thinkers, from von Neumann and Wigner to more recent voices, have suggested that consciousness might be the thing that terminates the chain. If you can move the cut all the way up, the only thing you cannot put into superposition is the first-person fact of experience. In that view, consciousness is not an epiphenomenon. It's a terminus where possibilities become facts. This is not mainstream physics, but it's a coherent position once you accept the structural parallel between measurement and experience. You might ask, is this just philosophy sneaking into physics? To some extent, yes. The measurement problem has always been philosophical because the theory itself uses the word measurement without defining it. Bell famously criticized this. Physics should not hide an observer in its axioms while pretending to be objective. The stubbornness of the problem, a century of debate, suggests it's not merely a technical glitch, but a signpost pointing to something deeper about the relationship between description and reality. There are three broad responses physicists and philosophers take. One, deny the gap, such as the many worlds interpretation. All outcomes happen. There is no single collapse. The appearance of a single outcome is explained by branching and self-locating uncertainty. The latter means, after branching, but before observing the outcome, a branch inhabitant, or the observer, does not know which branch they occupy. This removes the need for a special role for consciousness, but at the cost of multiplying worlds and changing the question from why this outcome to which branch am I in. Many find this move elegant, others find it metaphysically extravagant. 2. Accept the gap physically, such as those objective collapse theories. Here, collapse is a real physical process, perhaps triggered by mass, gravity, or some new dynamics. These theories can be tested in principle because they predict deviations from standard quantum mechanics at certain scales. Most versions do not involve consciousness, but some hybrid proposals do let conscious states modulate collapse parameters. 3. Exploit the gap. Let consciousness select. This is the boldest move. Consciousness plays a causal role in selecting outcomes. There are flavors of this idea. Some propose that consciousness only chooses among outcomes already allowed by the Born rule, preserving standard statistics. Others suggest consciousness could bias probabilities in subtle ways. The empirical stakes vary. Some versions are designed to be compatible with all known experiments. Others make testable predictions, though those tests are fiendishly hard. Now, a cinematic thought experiment. Picture a sealed lab. Inside, a scientist measures a quantum system outside. Another scientist waits. From the inside, the measurement yields a definite result. From the outside, until the lab is open, the whole lab could be described as a superposition. Who collapsed the wave function? The inside observer. The outside observer, or did nothing collapse until some later event? Now, add a twist. Suppose both the inside and outside observer apply quantum theories to analyzing their observations. For the outside observer, these include the quantum system inside the lab, plus the inside observer, who is also using quantum theories to analyze the quantum system. Does that change anything? The question is not just a parlor trick. Fraukiger and Renner showed that if you try to treat quantum theory as a universal description of all systems, including a system that contains another observer who uses the same quantum theory, contradictions can arise no matter what interpretation of quantum mechanics they use. The paradoxes force us to confront the indexical question. Why does this consciousness experience this particular result? That is the same kind of question the hard problem asks about experience itself. If you ask me, as someone who loves equations and metaphors in equal measure, the stubbornness of these problems is a kind of opportunity to explore the deepest of reality. If consciousness plays a role at that boundary, it need not be mystical or magical. It could be a subtle, logical interaction that preserves the statistical structure we know while filling in the indexical facts we experience. So next time you watch a photon hit a screen, or feel the red of a rose, pause for a moment. You are witnessing the universe. Choose one story among many. That choice, whether it's made by decoherence, by collapse, by branching worlds, or by the quiet agency of consciousness, is one of the last great mysteries at the edge of physics. And standing there, at dawn on a cliff, we are both the observers and the observed.